This video provides a brief review of how to solve linear equations that start with one or two terms on each side of the equation. Our first equation starts out 2x plus 5 equals 9. So you'll notice that on the left side of the equal sign we have two terms, 2x and 5, and on the right side we just have a 9. In this particular problem, we only have one term with a variable in it, that 2x. So my first step is going to be to try to isolate that and eliminate the term that's on the left side of the equation with it. Anytime you want to eliminate an entire term from one side of an equation, you use opposites. So this is a plus 5, so to eliminate that plus 5, I'm going to subtract 5 from the left side of the equation. When I do that, it means that I also have to subtract 5 from the right side of the equation to keep the equation in balance. So the minus 5 and the plus 5, those turn into a 0, and when you add 0 to anything, you're just left with what you started with, which is the 2x. So on the left side, I get 2x, and on the right side, I get 4. So now my equation is down to one term on the left side, one term on the right side. So now I just want to get the x by itself and eliminate the 2. Well, the operation that's connecting the 2 to the x is multiplication, so the way I get rid of that is with division. So I divide by 2. This 2 divided by 2, that's the same as 1. So I have 1x equals 2. And 1 times x, well, 1 times anything is the anything, so 1 times x is just x. That means x equals 2 is my solution. Now if I want to check my solution, I go back to the original equation that I had, 2x plus 5 equals 9, and I replace the x right here with the number 2. So I have 2 times what I think my solution is, which is 2, plus 5, and I want to know, does that equal 9? Well, 2 times 2 is 4, plus 5, does that equal 9? Yeah, 4 plus 5 is 9. So I get 9 equals 9, that checks. Let's take a look at another example. Negative 4x minus 6 equals 10. Similar type of problem in that I have only one term with a variable in it. It's right there. So my first step is to try to get that by itself, which means I need to get rid of this minus 6. Well, to undo subtraction by 6, you need to do the opposite, which is add 6. And if you add 6 to the left side of the equation, you have to add 6 to the right. The minus 6 and the plus 6, that's 0, so that goes away. I'm left with negative 4x on the left side and 10 plus 6, which is 16 on the right side. Now that I have one term on each side, I want to get x by itself, which really means I want to get positive 1x. And so I notice that the x is being multiplied by negative 4, so to get rid of that, I have to divide by negative 4. Now sometimes students get confused about whether they're supposed to choose a positive 4 or a negative 4. And the way you know is you need to keep your eye on the prize. You got to know that your goal is to get a positive 1. So if you have a negative 4 and you're going to be dividing, you have to divide a negative by a negative to get a positive 1. So that's how you know it's got to be a negative 4 that you use. On the right side, 16 divided by negative 4 is negative 4, and 1 times x is the same as x. So my solution is x equals negative 4. And if I want to check my solution, again, you go back to your original equation, negative 4x minus 6 equals 10, and I put what I think is my solution right there where the x is. So I have negative 4 times what I think is my solution, negative 4 minus 6. I want to know, does that equal 10? Negative 4 times negative 4 is positive 16. Minus 6. Does that equal 10? Yeah, 16 minus 6 is 10. I get 10 on both sides. That checks. Okay, this one's a little bit different in that my variable is on the right-hand side, but that really doesn't change anything about the process that you go through when you solve. So there's only one variable here, and it just so happens that it's with the term that's on the right side. But I still want to get it by itself. So it's important that I view this as a negative 2x here and a positive 4. So I want to get rid of that positive 4 that's on the right side with the variable, so I have to use the opposite, which is negative 4 or minus 4. Now I have 3 minus 4, that's negative 1 on the left. The positive 4 and negative 4, that's 0, so that goes away. And I have a negative 2x on the right. Now, once I have one term on each side, I look and I say, okay, I want to isolate the x, so I need to take that negative 2. What I really want is a 1x, because that's the same thing as x. So to turn a negative 2x into a 1x, I need to divide by negative 2, because negative 2 divided by negative 2 is positive 1. When I divide on the left side by negative 2, a negative divided by a negative is a positive. This is just going to be a fractional solution. And that's okay. You don't need to freak out if you get a fraction. Sometimes fractions are solutions to your equations. Now, same thing, if I want to check, I go back to my original equation. And I take my solution and I put it in where the x is. So is 3 really equal to 4 minus 2 times 1/2? Well, to check your solution, you need to be careful about your order of operations. Your order of operations says you need to do your multiplication first. So 2 times 1/2 is 1. Is 3 equal to 4 minus 1? I think so. 3 equals 3. So those are 3 different examples where you have one term on one side and 2 terms on the other side. Now let's move on to some examples that have 2 terms on each side. So you'll notice in this one I have a variable term and a constant term on the left. I've got a variable term and a constant term on the right. So the first thing I have to do is decide which side do I want my variables on. And if you've never done this before, sometimes you can kind of get lost in the process. So my tip is always to write down which side you want the variables on and which side you want the constant terms on, because that's going to be your first step, is to move the terms to the correct side. So the truth is you can put the variables on either side, the constants go on the other side. I just chose the left side for my variables. So the first thing I'm going to do is move the variables away from the side that they no longer belong on, or where I don't want them. So you'll notice that I said I wanted my constant terms on the right hand side, so I don't want this 10x here anymore because it doesn't really belong. So I need to get rid of it. It's a positive 10x, so I'm going to subtract 10x. If I do that on the right, I have to do it on the left. And then I'm going to write down what I have. I've got 2x minus 9 equals, now be careful here, this negative 11, or that minus sign turns into a negative. So you have a negative 11 on the right side. Then I go back and I look and it said, oh, I only want variables on the left side and I want my constant terms on the right side. So this minus 9 doesn't belong on the left side because I only want variable terms there. So I need to get rid of the minus 9, which means the way I get rid of a term from a side that I don't want is using opposites. It's a minus 9, so I'm going to put a plus 9. And then I'm going to write down what I have left. 2x equals negative 2. All right, now I've got my terms on the correct side. I've got variable terms on the left, I've got constant terms on the right. The last step is to just eliminate the coefficient of x, the 2 that's next to the x. So the way I'm going to do that is with division. I'm going to divide by 2, and that gives me x equals -1. And if I want to check it one more time, you're going to go back to the original equation and substitute it in. And this time I have to substitute it in both places where the x is. So I've got 12 times -1 minus 9. Does that equal 10 times -1 minus 11? I think both sides are -21. So that checks. All right, 4x plus 3 equals -3x plus 17. First thing I need to do is figure out which side I want my variables on and which side I want my numbers or constant terms on. So I'm just going to do the same thing I did in the last problem. I want my variables on the left and my constant terms on the right. So I'm going to look for where my variables are and move those. I've got a -3x on this right side, and it doesn't belong there because I don't want any variables there. I only want constants there. So I use opposites. This is a -3x. To get rid of it, I put a +3x. Then I write down what I have left. 7x, 4x plus 3x is 7x, plus 3 equals, this is going to be a +17 that's left. Then I look at what I have. I want a constant term on the right. I've got that. I only want variables on the left, and right now I have a constant term, so I need to get rid of this +3. The +3 I get rid of with a -3. And then I write down what I have left. 7x on the left and 14 on the right. Now that I've got one term on each side, now I can just eliminate the coefficient, this 7. That's connected by multiplication, so the way I eliminate it is with division. That means I have x equals 2 as my solution. And if I want to check it, go back into the original equation and plug it in where the x is. So I have 4 times, my x value I think is 2. Is 4 times 2 plus 3 the same as -3 times 2 plus 17? 8 plus 3 is 11. -6 plus 17 is 11. Yep, got it. Solution is x equals 2. Okay, last one. Notice that you've got variables on both sides, but you only have one constant term. So in a case like this, you could technically move your variables to the left and your constant terms to the right, but since the only thing I already have on the right side is a variable term, I'm going to switch it up here, and I'm going to put my variables on this side and my constant terms on this side. So now if I come over here and I say, okay, variable terms on the right, I've got that. I only want constant terms on the left, but I've got this variable of +6x, so I need to get rid of that by subtracting 6x. Remember, when you're moving the entire term, you always use either addition or subtraction or opposites. So on the left side, you've got -9. On the right side, you have -2x. And you're trying to get x by itself, just a 1x. So at this point you need to divide by -2. And a negative divided by a negative is a positive. So my solution is 9/2. And you can leave it like that. You don't need to switch it to a mixed number. And if you want to check it, 6 times 9/2 minus 9, does that equal 4 times 9/2? Again, so is 27 minus 9 18? I think so. Those check. So my solution is 9/2. That's the first review of solving linear equations.